Okay, that was a couple of weeks ago. So, a couple of weeks ago, I thought I understood stateful stream processing, the general term, what it means, how to use it. At the time, I thought that stateful stream processing is only about stateful aggregations. And it was about structured streaming, so I tweeted happy to announce what I found. To my surprise, people from Confluent, they are very picky at this, stream processing these days. They immediately responded that it's not, 100% true, because stateful stream processing is not only about aggregation, but also about joins, about arbitrary stateful processing in Spark structured streaming, but there is also streaming limit and streaming something else, I forgot. And given this is my first time, looks like I need to fill out the gaps and we'll see what I miss. Okay, so internals of stateful stream processing in Spark structured streaming. Yesterday, I gave a talk about extending data sources in Spark 244, and I expected more people than I can see today. So I'm stressed, doubled, or if I may put it this way. Okay, so I'm Jacek Laskowski, and I've been with Spark for the past 5 years, and I can't imagine a day without Spark, to be honest. Yeah, I'm paid only for doing consulting with Spark first, and then perhaps Kafka Streams with Scala, and the last but not least, SBT. It's not included here. So I'm doing development. Given my age, I still believe that I can be a good coder. I said it a few times already. No one wants to pay me for doing, full-time coding yet, but I'm working on it. I'm doing consulting. People love when I talk, or that's what they pay me for. So that's my understanding. Training, because it's easy to to quote, and speaking, just like today. So welcome all to my talk. You may have seen some of these slides already as part of my internals of online books. I'm writing 5 books already. I'm thinking about 2 more. And one of them is about structured streaming, and you can find more details about this topic in one of these internals of online books, the internals of Spark structured streaming. You can find me at this email address, jacek@yapila.pl. Just contact me, ask questions, but I prefer if you use, when you use Stack Overflow, use this tag, Spark structured streaming, and I'll know that you've got questions, okay? Thank you. Any questions? No. Good. So, friendly reminder, yeah, I used to use Twitter a lot. Okay. Feeling younger. Good. Okay, so I've got it. So, why should you care about stateful stream processing? Well, we all are using Spark, okay? You may or may not be using Spark structured streaming. There are other tools like Flink, did I say it, and others. So among these streaming solutions is Spark structured streaming. Quite recently, they've been working on stateful stream processing, and they introduced this concept of state. Now the talk is about how Spark structured streaming uses state internally, so you, in case of problems in production, may use this knowledge for your, own purpose. I'm leaving it up to you, but everything counts, just like Depeche Mode song. Okay, so stateful stream processing. What is it? Stateful stream processing is just stream processing with some state. The state can be explicit or implicit. For me, making this distinction is just to say whether you as a Spark developer have access to the state or not. It's not about, making the state available to data scientists or data engineers. It's for Spark developers, okay? So if you've got access to the state, for example, via arbitrary stateful stream processing, you may, get a hold of it. So state is simply a collection of keys and values. Okay, that's it. It was something like, that's interesting. Why would I expect something else? Okay, so it's just a key value store. You can, and what is a key? Key is something you, for example, group by or join on, right? So it's a key. This is the key information you store as a key in this key value store. Value is the current state for this key, correct? So this key value store maintains the current state of your stateful stream processing. We've got two kinds of stream processing modes in Spark Structured Streaming. One is micro-batch, another is continuous stream processing. I will not discuss continuous stream processing because, well, it does not support stateful stream processing, and it's not announced as ready for prime time yet, okay? In structured streaming, you may see some kind of state when you use streaming aggregation, arbitrary stateful streaming aggregation. It's just a special kind of streaming aggregation. Also, stream join. Looks like stream batch joins are handled differently, no state involved. Streaming deduplication and something I call streaming limit. It's just to denote, to name the operators, physical operators that are used in your query plans when you look at your query, structured query, okay? So you will see this aggregation, and aggregation and stream joins are the topic of our talk, okay? While I was working on the slides, I was thinking about this 40 minutes, and given we are 10 minutes, we've got 10 minutes already, half an hour should be fine for this streaming aggregation and stream joins. Okay. Obviously you can find more information in my online book. It's free of charge. You don't have to pay for this yet. Yeah. People seem to ask me, how long it's gonna be free of charge, and that gives me this thinking. Why are they asking about it? So perhaps they need to pay for this, which would be fine if I could earn a little bit more, right? So I'm thinking of it. Okay, so going back to this state store. So state store is just key value store. To my surprise, after spending few weeks with Kafka streams, which uses RocksDB under the covers or in-memory key value store, to my surprise, I had to change my thinking about key value store in Spark Structured Streaming because they decided to rely on HDFS. Now you might be thinking, why HDFS? We'll get to it. So state store is abstraction of key value store. Okay, so you store keys and values. They represent your state. Okay, good. You've got abort, commit, get range. All these methods are part of this abstraction, part of this contract. So if you need some more sophistication in this, state store implementation, you can implement your own state store. Yeah, that's possible. It's identified by operator and partition ID. Honestly, after 5 years working with Spark, I still am not very comfortable thinking about this hash partitioner and all other partitioners you may be using for your Spark applications. How many times do you think about partitioning? I don't think that it's very often. It's like you assume that your data is partitioned somehow, okay? And this partitioning, well, by default, it's by this hash. And depending on the operators you are using, this hash might be by key you group by, you use for joins, or some other key, okay? This is very important because now this key is used to point at a specific state store that contains state for this particular key and operator. What is operator then? Operator is physical operator. This is the beast that's responsible for executing your query. Every query is pardon my pronunciation. Every query is, that's really hard. Mark, how to pronounce it? Query, okay. That's obvious, right? Okay, so every query, but for me, oh man. Okay, every queue, oh no. Every query is identified by operator and partition ID. Partition ID, we cover it. Okay, how many partitions do you have for your groupBy operator by default? 200. Why 200? No one knows. But they proved that 200, I asked this question, a few times already. It's on Stack Overflow. There's, some conversation about it. They decided that 200 is good enough, okay? In most cases, 200 worked fine. If you don't like it, change it. But once you change it, you have to keep it. Number of partitions is something you cannot change after restart of your structured query. So think twice before you decide on the number of partitions. Why is it important? Number of partitions is exactly number of state stores. Okay? Number of files on HDFS. So given all this, you need to think twice about how many partitions to use. Well, it's always important, but why did it happen? But this is even important for stateful processing. So you've got this operator and partition ID. So partition ID covered. Operator is this operator, physical operator that's part of your query plan. Query plan, every structured query, every streaming query goes through this pipeline, query execution pipeline. In structured streaming, it's incremental execution. So every micro batch or once in a while, or at startup of your continuous stream processing, this query execution happens, and you will get this physical plan. So this physical plan will give this information about operators that are interested in maintaining state. Good. So HDFS-BackedStateStore is the only known implementation of this state store contract. This is the, but again, you can implement your own. So this HDFS, so again, HDFS is used to store your state. Why is it important? Think about how Spark works. It's very low level now. Once you describe your processing, whether it's stream or not, or batch, you will create RDD lineage eventually, okay? If you've never heard of it, fine. If you did, fine too. You shouldn't be using RDD lineage these days, because once you start using RDDs directly, you will lose all the optimizations that Spark SQL gives you out of the box. And that's exactly the reason why we are using Spark SQL and Spark Success Streaming in the first place. You try to have, you want to leverage all the knowledge these crazy people from Databricks, embedded in this code. It's very clever. So you'd rather not avoid all these optimizations, unless you are more clever, and you should be working for Databricks then. So I am not. So HDFS is used for this store, and now RDDs will get executed, and these RDDs will get transferred into set of tasks. How many tasks will we have? This is exactly the number of partitions in this RDD. In the last RDD, how many RDDs do we have in one single logical query plan? Well, we can have one or thousands. I've never seen thousands RDDs in use, but still it is possible. It's just a graph of RDDs. Okay, so why is it important for this state store? Because every RDD represents one single step, well, it's part of a single step of this query execution. So you may see more than just one single state store for your structured query. Every operator has its own partitions, and every partition will have its own their own state stores. So the number of state stores may be huge. So default and only implementation, the state store, yeah, and created when state store utility. I'm using utility to talk about objects, Scala objects. Just you know, few days ago, I just, well, it happened before, but, you know, it comes from time to time. Scala object is kind of like a singleton. So once Scala object is used on a JVM, it's only one instance available. And they were so clever, you know, it's not easy to spot while you are reviewing, you know, source code. While you are writing, you know, Scala code, it's obvious. I've got an object, it's just one single object on this JVM. But if you review one single method, you may just miss this information that it's part of this object. An object is loaded once by JVM. And this JVM I'm talking about is executor JVM. That's how they maintain global registry of all state store per executor. Okay? Wish I had a diagram about it. I'm working on it. So, state store provider is the guy who is responsible for providing state stores. Okay? It's a contract. So, there are methods like getStore by version. Yeah, we are versioning, or we have state stores versioned. And init store, state store ID and supported custom metrics. All these metrics are then available so you can listen and to all the metrics emitted. This is available through a Spark listener interface, this general interface, or there are specialized interfaces for Spark Structured Streaming and Spark SQL too. So, so getStore, you might be thinking, what is this version? We'll see it in a moment, okay? Only 20 minutes. So there is this internal configuration property that says what state provider to use. And by default, it points to this. It's internal property, so don't use it unless you know what you're doing. So it just says what implementation to use. And by default, there is only one known implementation, HDFS-based implementation. And that's what this property points to, okay? And again, it's identified by operator and partition IDs, exactly similarly to state stores they manage. Okay, good. So, and this HDFS state store provider is just the guy who is responsible for making sure that these state stores are available for all the computations. Okay, and what's interesting is that this delta, it has nothing to do. I talked to a few people who know more about Delta Lake, and it has nothing to do with Delta Lake, but might be that some concepts are similar. Okay. Okay. So what are deltas and snapshots? Delta, for every microbatch, again, I wish I had a diagram about it. Every microbatch, you are processing different data, okay? But you need to drag state along this processing. So every microbatch, every execution of this kind of like batch query that's part of this streaming query, you will have access to state. This state is loaded, so version 0 for batch 0 is loaded. It's empty. Then you do some changes to this state. You aggregate it on this key, so you've got different count. You did join on this, and watermark expired. You've got different state. All this information is stored regularly in Delta files. These Delta files contain changes across versions of your state. Once in a while, this provider will kick off this process of snapshotting of all these 10, by default it's 10 Delta files, and make it available as a combined state in a snapshot file. So you will see lots of Delta files and snapshot files in your checkpoint location under state directory, under operator ID, under partition ID. We'll see it in a moment, hopefully. Okay, so there is something I found very interesting. I knew how to do it once I learned about it, but if I had been asked about it before seeing this code, I would definitely not know the answer how to do it properly in Spark. In other words, They are using something that, okay, just a little bit of Spark architecture. We are talking about driver and executors. We've got hundreds of executors and just one driver. Driver has to be up and running to have your application up and running, correct? It could be on your local machine, it's client mode, or it could be in as part of your cluster, it's cluster mode, speaking about cluster managers. So now, think of it. We've got this driver and executors. All processing usually happens on executors. There are some, processing that happens on the driver, but it's very not very often. So usually, processing happens on executors. Now, how to let the driver know what state stores are available on executors? It's distributed environment. So there has to be some way of communication, intercommunication between executors and the driver to announce new state stores. And they decided to rely on something that was part of Spark for ages, RPC environment. It was, back then, it was based on Akka. They decided to rewrite it using Netty to make it better, hopefully. And so they are using RPC environment, so executors send messages back to the driver to announce what state stores are available. Why is it important? Because this information is used for planning of your low-level RDDs. Among them is state store RDD. RDD is made up of 5 properties. Out of them, 2 are important. And we are speaking about one optional, preferred locations. If you define your custom RDD and you provide preferred locations, these locations point to executors, your tasks, or your partitions, your data should be processed on. So this information is important to keep state in sync with the keys per partitions. Wish I had diagram. It'd be much easier to explain. I'm working on it. Next time, next Spark Summit. So just know that this state store is responsible for announcing what executors to use, and this information is thanks to the state store coordinator that tracks all the state stores that are available in your one single stream processing. You can have thousands of queries on your cluster, so you will see lots of network traffic going on between executors and the driver, or drivers. So state store RDD is just a custom RDD that's responsible for, just like RDD in Spark, it's responsible for executing this state store store update function. It makes this store available via implicit Scala implicits to these operators. Flat map groups with state exec, state store restore, state store save. They are for streaming aggregation, streaming the duplicate for duplication, and the last but not least, global limit exec. They are physical plans for all the streaming operators that I think all use state stores for your for processing. Okay. You can see them using this explain operator on your streaming query. So after you execute explain, you will see all these operators without this exec. They decided to remove this exec, so it's easier to read. Okay, and under the covers, the state store RDD uses this state store coordinator, RPC endpoint, that knows what are the locations of the state stores per information that's needed for planning this RDD. There are 2 kinds of planning. One is query planning at Spark SQL level, and another planning at RDD level. Okay, you shouldn't be bothered that much about this RDD layer, but since it's a talk about internals of stateful stream processing, it's worth to talk a little bit about it. Okay, now we are going up. Okay. So we've got 15 minutes left, 5 minutes for questions. Yeah, okay, 10 minutes. So, streaming aggregations. So streaming aggregation is just a kind of a streaming query. So it's Spark structured streaming again, streaming query that's described. I can't express how excited I was when I started using this describe by. All what developers do while they are writing the query or queries, whether it's batch query or streaming query, is just to describe what's going to happen at runtime once you start your query. Okay? So, all Spark does is to take your query, rewrite it, and make it more efficient and execute it. Okay? You don't have to worry about it. It happens automatically. This binary code, Java code, is generated for you. So it's precompiled, it's compiled at runtime, so your queries are fast, as you may or may not imagine is possible. So by saying describe is that you describe this processing graph. It's a directed acyclic graph, just like it was in RDD days. Now it's with all these physical operators, logical operators, to be honest. So you describe your graph, processing graph, by using operators, high-level operators. They are high-level enough so Spark devs have time to optimize what you wanted to do. So whenever you say groupBy, or whenever you say rollup or cube, you will create this object, but eventually you will create aggregate logical operator. You know it already, okay? So this aggregate, aggregate logical operator is then planned, and it's planned every micro batch by this incremental execution, a custom query executor for Spark structured streaming that uses stateful aggregation strategy. It's one of the many strategies available that will transform this logical view of your query, low-level logical view of your query, into something executable. Okay, so this strategy will create a pair of operators, two physical operators. One is to restore state that will get pumped through the pipeline of your streaming query into this state store save exec. So eventually, after all the changes, this state will get updated and saved to HDFS eventually. Okay? So that looks like this. And at this point, I should be showing you, a simple streaming query. But we'll get to it after I finish these slides. Okay, 5 more and we're done, okay? So in a moment, I show you more how to look at it, okay? But when you look closer, you will see that at the top, you will see analyze query plan, then you will parse logical plan, then analyze logical plan, then optimize logical plan, and the last but not least, this is physical plan. There are 4 different versions of your structured query. There are more versions. 3 are hidden, cache and some others. So these 4 stages of query execution show that out of this aggregate operator at the top, you will eventually get this executable query plan that's made up of state store save and state store restore. Okay, you should be reading this query plan from bottom to top. So now at the bottom you've got your data, and going up are all operators that process your data. Okay, good. Questions? Yeah. So stream join. I cannot explain exactly what happens with stream batch joins. I know that they are not using state. I need to confirm it. I'm working on it. But definitely the only version of join or kind of join that uses state is stream join. Okay? So now in Spark 2.4.4, stream joins are supported. Definitely inner joins. Not sure about all the other, 6, 7 kinds of joins. But let's focus on just one single join, and then you can just proceed from it. So in Spark Success Streaming, streaming join is a query that uses join high-level operator. And whether it's, this Scala or Java join operator on this type called data frame or data set, it doesn't really matter, as a matter of fact, or SQL, they will all create this join logical operator. Again, the same things happen for streaming joins. You will write something, you think that you are clever enough, you wrote your query in the best possible way, according to your knowledge, current knowledge, and then Spark applies all the optimizations, and eventually you will get something that may or may not resemble what you wrote. Definitely, it's something people are not happy to look at very often. I love it, but not many people are so crazy. So, streaming joins generate join logical operators in your query plan. So, your query plan may or may not also use aggregations. So whether you are using aggregations for your joins, it's up to you. But think about the number of state stores used for your one single simple-looking streaming query. It may be quite a lot. Given that you usually don't change the number of partitions for your streaming query, 200 multiplied by 200, blah, 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 number of operators, there are quite a few state stores, all stored on HDFS. And why HDFS then? You might be thinking yourself. Well, the reason is that we are in distributed environment. All the processing happens on executors. So in case of any problems, you wanted to restart your query. So these queries have to start afresh. Well, afresh meaning that they start on new executors, on new machines, but they need to have this state available. So it's assumed that HDFS is a good fit for this use case, where executors may come and go. No. Dynamic allocation of executors is not supported by Spark Success Streaming, but by saying come and go, I mean you stop your query and you restart your query and you will have, rather than 10 executors, you will have only 3. Yeah, that's possible too. So they need to somehow figure out how to find the current state. And this is based on HDFS, fault tolerance and high availability and all the niceties. So again, incremental execution uses separate execution planning strategy called streaming join strategy for planning streaming joins. Eventually, you will see this nice looking streaming symmetric hash join exec. I'm yet to discover the reasons why they picked this name. Symmetric, okay, fine. Hash, we can guess this is by a hash that's generated for the keys, for the values. So yeah, at some point it will make sense. So stream join will look like this, okay? So eventually, as I said, you will get this physical plan with this symmetric hash join operator that's at the top in this, well, it's at the top of the bottom of this diagram. Not sure if... Okay, that's all about this as far as slides are concerned. So let's go back to this streaming aggregation. So you saw this, okay? And before I show you, we've got 5 minutes left. 5 for questions, so we've got a few seconds for demo. So do you have any questions about this? No, good. So now I'm gonna show you streaming aggregation live, okay? Woo-ha. So Spark reads stream and format. There are plenty of formats available. What I like for demos is just rate. I could use memory, but memory is more sophisticated. It's more for unit testing rather than for something that you can write in one single line. So format rain, format not rain. Rain was yesterday. Format rate and load. Okay. So we've got our left. This is for aggregation. So what do we have? Rates. Okay, so we've got this rates, and this rate is just, what is the type? Okay, so the type of this is just good old data frame. So we know it's data set of rows. So row encoder is used. for our data. We could have used some other type for this, but rows are fine. So now we may do something like groupBy, and then by we've got timestamps and values. So let's do value, and then we can just multiply it by 2. So we've got 2 groups, and then what else? And then we just write a stream, groupBy, and count, and then write stream, and then format and console, and then before I do this, let me do this. So I show you the query plan before I execute it, okay? So this is just streaming aggregation. So the streaming aggregation is described by this, format rate. So I'll get time-stamped values every second, and then I group it by to 2 groups by this modulo operator. So QExplain. Okay, we've got this query plan. So we explained what this query plan looks like under the covers, and something I haven't covered. Yes, I missed this, is checkpoint location. This query plan does not use checkpoint location. Well, it does use checkpoint directory, but I haven't specified explicitly as part of describing my streaming query. So it uses something that it's not here. It will, once executed, it will use some randomly generated directory for maintaining state, okay? This state will be local because I'm in local environment, but it could also be on HDFS already. By saying HDFS, I should have said HDFS compliant file system. So whether it's HDFS local file system, like whatever is available on macOS, or whether it's S3 or whatever, it's just up to you, up to your environment. Okay, so you see this query plan, and you can notice that there are 2 operators that are responsible for state management: state store restore and state store save. Okay, good. So let's execute it and let's see this in action. So query, write stream, and then format, and then console, and then option, and then truncate, and then false, and then start. Okay, so you've got streaming query. Hopefully, append mode. What's wrong? I need to change output mode to execute this query. Since we've got only 2 minutes left, I'm not gonna change it, introduce different output modes. No, and this is just to invite you for next Spark Summit, for my talk about, internals of Spark, stateful stream processing. Output modes indicate what state is gonna be emitted and what's gonna be available later on for next micro batches. So it also applies to continuous epochs, but since we are not discussing it, I'm not gonna touch it. So that's all from me. I couldn't show you this query in action without changing this query plan. I may show you this after the session if you need to see it. Now, time for thank you. And questions.
Any questions?
That the state store coordinator is responsible for getting the preferred location to get the state.
Yes, so what's the question?
The question is, if I have a Kafka partitioned topic, is enough if I build an aggregation but based on the same key of on which my topic is partitioned to be assured that there will be no shuffle when
no shuffle. So whatever format you use, whether it's Kafka data source or RAID or whatever, does not impact how state stores are managed. It's orthogonal. It's just something that it does not contribute to state stores. So it may or may not be useful to have your executors on the same machines where you have Kafka brokers. But whether you do this or not, it's again up to you. I would not recommend it. Some people say no, so think of your data as part of your Spark processing and forget about whether it's Kafka and how Kafka partition it. As a matter of fact, Kafka does not use the same, even though it is hash partitioning, they use some other algorithm to compute hashes. So if you compare a hash in Kafka and hash in Spark, you may get different results. That's at least my understanding at this moment.
So there is no way to control how can we avoid lot of shuffling?
We can control the number of shuffles by limiting number of partitions. And number of partitions is your configuration property of your streaming query. Once you set it, you need to keep that. Otherwise, you have to change checkpoint location because it's checkpointed. So every time you resume your query or restart your query, and you will use the same query location, you will have to keep that this number. And so, yeah, and then you may specify a number of partitions after groupBy or used for groupBy. So yeah, you can control it, but whether it has something to do with state stores, not really. Yeah, the number of state stores will get eventually be the number of partitions after groupBy. Yeah, that's correct.
Great. Thank you, Jake, for the excellent presentation, and thank you all for coming.
Thank you.